This is the video for Math 117, Section 3.1. So we need a little bit of algebra review. So we're reviewing the radicals and powers. Anything in the denominator can be rewritten with a negative power. And we're going to look at this one later, so we're not really that interested in this one right now. The square root of AB is equal to the square root of A times the square root of B. I can separate those out. The derivative, velocity is the first derivative, acceleration is the second derivative. So we're going to play with these for a minute, and then we're going to take the derivatives. So we need some derivative rules, and here they are. C prime is equal to 0, so if you take the derivative constant, that's 0. The derivative of x is just 1. If I have cx, the derivative would be c. And that comes from this next one. I can just multiply by the derivative. If I have c times x, we'd have c times derivative of x would be 1. And then the power rule, x to the n, the derivative of that is n x to the n minus 1. And then we can take derivatives separately. F plus g means I have two separate things added together. I can take the derivative separately. The same is true for this. We do not have a rule for multiplication yet. We'll do that in the next section. So these are the rules for this section. So looking at a little bit of a review before we get into the problems, we want to first rewrite these. So these are the rewrites. And over here we'll take the derivatives. So the first part is to rewrite. So this is y is equal to the square root of x. That's just x to the 1/2. This is y is equal to the cube root of x. That would be x to the 1/3. Square root of x cubed. That would be x to the 1/2 for sure, right? But it's cubed, 3/2. So you can think of the root as going under, just like roots underground. The root goes under. The power still stays a power. So this one here would be x to the 2/5. Don't overthink these or you end up with them backwards. The root goes under. The root goes under. If you're not given a root, then it's automatically a 2. Square root says square, it goes under. It's not a square power, it's a square root, square under. This is x to the 1/2. That's x to the 1/2. So I'm going to distribute that, and I end up with x to the 1/2 plus 2. And if you need to, pick up your calculator. 2 and 1/2 is going to give me x to the 5/2. Fractions are easier to take derivatives. Minus 2x to the first, which would be 2/2 plus 1/2. Pick up your calculator if you need to. 3/2 plus x to the 1/2. This is an easier form to take the derivative. That's what we're doing, so that's what we need. Now this x is by itself. The negative 3/7 is just a number there. I don't need to move it, but I do need to move the x to the negative 1. Same is true here. The 4/8, the 8 is not attached to the x. This is not 8x to the 3rd. This is 8x to the 3rd. So this is 4/8 x to the negative 3. So now to take the derivatives, we're just using the power rule. That's x to the n prime is equal to n x to the n minus 1. So y prime, now I'm taking the derivative of this whole equation. And in WebAssign, they give you the y prime. I won't give it to you on your paper. You'll have to write that. So y prime is equal to 1/2 x to the negative 1/2. Here there's a trick. If you're taking this minus 1, you'll do 1 minus 2, which gives me a negative 1/2. Y prime is equal to 1/3 x to the 1 minus 3 gives me a negative 2/3. So the denominator is not going away for the power here. This would be y prime is equal to 3/2 x to the 3 minus 2 gives me 1/2. This is y prime is equal to 2/5 x to the 2 minus 5 gives me negative 3/5. This is y prime equals 5/2 x to the 3/2 minus 3/2 x to the 1/2. Note that the x is not in the denominator here. 3/2 is a separate thing. Plus 1/2 x to the negative 1/2. These should be really easy, so don't mix. If you can rewrite them, they're real easy. Don't miss these fractions at all. If you have to, pick up your calculator. Don't be shy about doing it. So y prime on the second to last one here is going to be equal to negative 1 times negative 3/7 gives me a positive 3/7. Oops. X to the negative 1 minus 1 gives me negative 2. So the powers are going down here. You bring them out front. Bring the power down, x to the power down 1. Y prime equals negative 3 times 4 gives me negative 12 eighths, which actually reduces x to the negative 2. No, negative 4. Minus 3 minus 1. I almost missed that. So negative 12/8 reduces, well, 4/8 would have reduced here. So this would be negative 3/2, right? So I should have given you a reduced form anyway. So we worked some of these derivatives in class. For the first problems, we did these in class. We said that if both of them were going down and there's some wiggles in here, it can't be a parabola, so it can't be an x squared, but both of them are down or both of them are up, it means it's an even. So we either are looking at x to the fourth and negative 1/5 x to the fourth. Everything else is either a parabola, which we don't want because a parabola looks like this. That's a parabola in x squared. X to the fourth has more wiggles, so none of the rest of those could be, so it's between these two. If you can't figure this out without picking up your calculator, pick up your calculator, and if it graphs the right one, then you know you have the right one. But it is a negative x to the fourth, and the negatives mean that the even powers would start down. This one would be a positive x squared. So enough on those. Before we look at the next problem, note that this one has a maximum here and a minimum there. And we can find the maximum and minimum on a graph by going to second trace and looking at the minimum and maximum. It asks us for left and right bound. So we'll apply the rules to the rest of these. This is just a constant and the derivative is 0. I'll ask you something like this. If there are no x's, it's a constant and the derivative is 0. The constant means it was a horizontal line which has slope of 0. This is just a line, so the slope would be negative 2/3. Derivative of 2 is 0. The derivative of negative 2/3 t would be negative 2/3 times 1, t to the 0. T to the 0 is 1. We end up with just negative 2/3. So you can work it a lot, like what I just said, or you can just go, this is a line, slope is negative 2/3. This one you'll have to multiply. 12 times 3/4, x to the 11th. This is straight across. You'll take the derivative of x to the fourth, derivative of the negative 7x, and the derivative of 3. So we'd have 4x cubed minus 7. Really fast. You want to distribute on number 10, distribute. Here you'll have to FOIL this out. So let me review FOIL for just a second. We don't have a product rule yet. We will in the next section. So we'll have to FOIL this out to do it for this section. So this is y is equal to, I'm rewriting this. I'm not taking the derivative yet. So it'll be the first, the outer, the inner, the last. So I have x cubed. Outer is plus 7x squared. The inner is minus 3x squared. And the last is minus 21x. So my derivative will be 3x squared. I could have combined these first. I might should have. So let's combine those. That's x cubed plus 4x squared minus 21x. The derivative of 4x squared would be plus 8x. And the derivative of negative 21x is minus 21. We know that cx, the derivative is just going to give me c. So that's one of the formulas. The rest of these are the power rules. So let's look at another example here. If I have something like this, I can distribute the square root of x. This actually says 3x cubed over x to the 1/2 plus 7x over x to the 1/2 minus 4 over x to the 1/2. And that means that this is, I'm just rewriting, not taking the derivative, 3x to the 3 minus 1/2, it gives me 5 halves. 3 times 2 is 6. Now pick up your calculator if you need to. I might need to. And that needs an x in there. And this will be 7. X to the 1 minus 1/2 gives me 1/2. And then minus 4. This is in the denominator, so I can bring it out. This is x to the negative 1/2. So note that if I have, well, let's take the derivative first. So y prime here will be 3 times 5 halves, which is 15 halves, x to the 3 halves. 5 minus 2 gives me 3. And there should be an x there. Plus 7 halves, x to the negative 1/2. Negative 4 times negative 1/2 gives me a positive 2, x to the negative 3 halves. Pick up your calculator if you need to. Now remember, if I have something like y is equal to negative 5 over x cubed, this is rewriting this as negative 5x to the negative 3. So y prime would be 15x to the negative 4, Just remember, you've got enough examples now. You should be able to figure out what you need in order to get these correct. So for this one, I'd have to separate this out. It'd be square root of 5 times square root of u. This square root of 6 is not tied to the u here. This is just going to be the derivative of square root of 6. Notice there's no x here. The derivative of this would have to be 0. If there's no x, my differentiating variable is x, and there's no x in there, so the derivative is 0. For 21, you'd have to rewrite and FOIL this out. We want an equation of the tangent line, so I know that I want the slope of this, and I can either get it on my calculator with the dy dx, or I can do it by taking the derivative and then putting it in. But I know for sure I have x minus 1 plus 7, and I need a slope right here. I need to put the slope. So there's the form of the line, just given the point, I need a slope. So if I go to my calculator and y equals, I'm going to put this formula, and we want an equation of the tangent line. So all we want to get is the slope out of here. I get x to the 4th, x to the 4th, plus 7x squared, minus x. To get the slope out of here, I'll do second trace dy dx, which is 6, and put in 1, because that's my x value. I get the slope is 17. So I'll go back here and I'll put in the 17. It doesn't ask to simplify it, so you can leave it just like that. The second one gives you exactly the same thing to do. Find the equation of the tangent line. It asks you to illustrate by graphing, but I'm not asking you for the illustration. For these extra questions on 25, for a few down here, they're really just saying when is the derivative 0, and that's when it has a horizontal line as the tangent. So we're looking here, if I was looking at a parabola, the horizontal line would be down here. Anywhere else I draw a tangent line to this curve, it's not horizontal. So f prime is 0. That means when is the slope 0, and it's when it has a horizontal line as the tangent. This says when is the slope positive? Well, the slope is positive when it's going up, when the function itself is going up, and the slope is negative when it's going down. So these should be pretty clear now as what you're doing. F prime is an even function. Well, this was an odd, and if we take a derivative of this, we end up with an even function. So if f prime is even, what was true about f is what they're asking you. For number 27, you'd have to rewrite. This would be 3x plus 2/3 x to the negative 1. So 2/3 of 3 is not with the x. It's not going to the numerator. For 33, their lines are parallel if they have the same slope. So the slope of this line is 6. Y equals mx plus b. Here's my mx. The slope is 6. So if I take the derivative, set it equal to 6, I'll get what my, well, I know the slope is. I know the slope is 6 here. So what I need is my x and y's. So I'm putting something in there, and I don't know what it is yet, and then plus my y value. So once I get that slope is 6, I take the derivative, find when the derivative is 6, and that'll give me an x value, and then I have to plug it back in to y.